Okay, class, this is Professor Brown again. Welcome to Week 9, where we'll be covering Chapter 7, Host Data and Application Security. This is a pretty lengthy chapter and covers a lot of different topics and has a lot of points for the Security Plus exam. So as you can see in your text, in the very beginning of the chapter, they have a lot of the learning objectives lined out here, including explaining what a threat actor is, the impact associated with vulnerabilities, scenarios for implementing secure protocols, and there's a lot of those, security implications for embedded systems, and basically how to summarize the application development environment and deployment of applications. So a lot of software development lifecycle stuff. Also on page 204 and 205, of course, we have our definitions and terminologies. They cover threat actors and attributes. So let's go ahead and dive into that right now. So basically we need to explain who a threat actor is, what their attributes or characteristics are, explain the impact of vulnerabilities that they exploit, and explain the security implications of embedded systems and how to basically secure everything against this. And we touch on, again, some software development lifecycle, which in my opinion, software development is one of the most critical areas of security. It does not get enough play. It does not get enough attention out there in the community because as programmers develop applications and software, typically security or security consciousness is the last thing in their mind, because most of the time they are under the gun by management, and the security is one of those, oh, well, we'll get to that later. We'll get to that with a patch. And that's a big problem. So let's talk about the different types of threat actors. So first are our script kiddies. And this is a derogatory term. Don't ever call a hacker a script kiddie. They will get rather ticked off at you. But a lot of us are, because we go and we reuse everybody else's scripts and applications and things of that nature. So basically, those of us who are using techniques are really script kiddies in the simplest forms. But a lot of times these folks who are just getting into the offensive security area and they have not developed their own scripts or tactics, they kind of fall into this category. They use well-known tools. They use information that they pull off of, say, GitHub or SourceForge, and they play around, they test stuff out. Then we have our hacktivists, and hacktivists are basically folks who hack for a cause. Now that cause might be political in nature, it may be non-political in nature. Most of the times it is political in nature in some way, shape, or form. The resources that the hacktivists typically use have to do with denial of service, because they are either defacing websites or denying service to a source of information. It could be a website, it could be a file upload, it could be different types of things on the internet that users will see, and it will get them attention. Organized crime has evolved in the internet age and gone online. These folks use the dark web in order to sell wares. They also basically are organized in an attempt to gain illicit funds. There is no political issue here. So that's the big difference between organized crime and hacktivists. There is no they're motivated by money, and simple as that. The nation states and the APTs, are advanced persistent threats. In recent years, these have gained a lot of attention, and nation states are hacking into foreign governments, not just foreign governments, but also companies that are used by foreign governments. So a lot of times, the Chinese, North Korean, Russian hackers, they won't target the U.S. government directly. They will, don't get me wrong, they will. But a lot of times they will go and target the vendors that the government is using. All right, they will go after the defense contractors and aerospace firms and organizations such as that, because those may pose a less barrier of entry into which they can potentially pivot into government assets. Insiders are rather different problem altogether, and it's hard to defeat insiders, disgruntled employees, or those of them who basically say, forget it, I'm going to burn it all down, I don't like this company, and they commit crimes in the process, whether they leak information or they basically, for lack of a better term, burn stuff down, shut down systems, erase data, etc. Insider threats are a big deal. This is why we have to vet personnel. This is why we have to take good security steps on termination of employees. And then we have competitors. And yes, corporate espionage is a thing. It is widely known, but very limited in scope, or actually not really discussed a whole lot. Although a lot of companies try to ethically look up information against their competitors through public websites, which is legal. They also sometimes go that extra step, typically through social engineering or other type of facets, to learn as much as they can about their competition in order to gain an edge. So OSINT is a big part of this threat. So Open Source Intelligence, or OSINT, has an entire framework. This is used in phishing. It is used in information gathering. There are different types of applications, such as Shodan or ThreatCrowd. Shodan is one of my absolute favorites, so I always like to do a little bit of a demo with Shodan. Let me just kind of pull this up here. If you go to shodan.io, all right, and you can analyze different aspects of the internet in mere seconds. All right, so you can log in or register. You can use a Google or Twitter or any type of association you want. So I'll just go ahead and use my personal Google account. I think I've done this before. Oh, that's not good. I guess I have not signed up for that. Let me try my CCDC account. Nope. Alright, we'll go ahead and go back and we'll just try a simple let's look at port 5901 or port 3389. Windows, remote desktop. Let's see what we can find. Oh my goodness, look at all this. So you can do a lot of just open intelligence. Shodan just goes out and scrapes stuff off of the internet, houses it in a database, and basically what you're doing up here is you're just doing a query. Alright, so here I found 47 port 3389 instances. One of them here in the US. Sometimes they'll give you screenshots. Sometimes they won't. Alright, sometimes you can go into it. A lot of times you may find that these are honey pots. Okay, you can look up services. You can get different information. Again, this is just nothing more than what they have scanned and captured on the internet, but it's out there. It's open source. So I just wanted to kind of point that out. All right, so different types of vulnerabilities that we can have to be aware of. Configuration issues are one of the most problems that I see in a lot of times when I do an assessment or an audit. Ports that are left open, simple passwords that are left on there, default passwords. User issues. So users may have advanced privileges or escalated privileges when they do not need them, or access to file shares that they do not legitimately have a need to know for. Zero-day exploits, there's nothing we can do about zero-day exploits, period. 0 days are unknown to us, and we can only hope that they are exposed and a patch is released quickly so that we can take preventative steps. And different types of other issues that may crop up from time to time about vulnerabilities, such as securing protocols and IoT devices, other types of issues like system sprawl, elasticity, especially in virtual networks, out-of-date software. That's a big problem as well. So embedded system security, and you see this with IoT a lot. IoT is a big problem because a lot of manufacturers out there that are connecting their whatever to the internet are not IT security types. So they do the bare minimum basics, and then all of a sudden your refrigerator has a remote desktop or SSH connection poking out to the internet, and you're like, what? Somebody hacked my refrigerator. I've seen all kinds of crazy stuff when I go to DEF CON and I go through the IoT village. It's not just your home routers and your access points that you can buy from Best Buy or Fry's or Micro Center. It is anything that can connect to the internet. And they have an entire IoT village where people just go there and try to hack into these devices so that we can tell the manufacturers so that they can make them stronger and more secure. Application vulnerabilities underlie a lot of the problems. Again, like I had said previously, application developers, a lot of times they are not thinking about security. They just want to get their product to market. They want to make money, and they don't do a lot of due diligence in testing for security. These come in the form of input vulnerabilities, especially if there's a back-end database where you might have a SQL or cross-site scripting vulnerability, or more often than not, a memory vulnerability where you have a buffer or heap overflow that is susceptible, where you can execute code because you are not clearing out your memory in a proper fashion, like good programming practice teaches us. So it's all about prototyping. So with secure programming, we need to test. And the software development lifecycle needs to have a security element in it in order for us to test our application or our software against threats. And there's different types of testing. There's unit testing, there's integration testing. Actually, that's the next slide. I won't get to that quite yet. But the model that you see here, the prototyping model, you code, you test, you deploy, you get feedback, you get more requirements, and it's a constant cycle. Security should follow this as well. Security should be a big portion of the prototyping process. So specific types of software testing that we see all the time are unit testing, integration testing, system testing, user acceptance, and regression testing. So with unit testing, this is a function to make sure that the device or the whatever works. Okay, and the program is clean, it doesn't error out. Integration testing is where we take the unit or the software and we integrate it into a larger system to make sure it's not going to foul up that system. System testing comes next, where we test the system as a whole. This is often done by a separate testing team, an independent team. Then we have user acceptance testing. This is where the end users will use and provide us feedback. And a lot of times user acceptance testing is nothing more than, oh, I liked it, or oh, this sucks, I don't want to ever use it. And we have to dig into those facts and go, well, what did you not like about it? What did you like about it? How can we improve upon that? And it has a lot to do with the front end or the user interface or UI. And then regression testing. Once a system is deployed and users are using it, whenever a change is made, not only must we have to make sure that change is tested, but all of the systems that might be affected by that change, we've got to go through and test them too. That is called regression testing. Even though we may not be touching those affected systems directly, the system that we are changing may have an indirect role in a process for another system. So we have to regress and test all those other systems as well. Patch management. Patch management is a whole big worrisome issue with how we deal with systems. And a lot of times it's not just the operating system that we have to worry about. If we are doing the software development ourselves, we have to track our changes. We have to ensure that if we come across an issue, we do a hot fix for that problem. And that is an interim, okay, I just need to write this code so I get this fixed as quickly as possible for this customer because they pay me the most money. A patch is something more generalized. And a patch is where we push out on a regular basis code that fixes a problem, okay, that we have documented. And a service pack is basically a larger portion of code that does a general upgrade to a system or adds features or applications to that system. Okay, so some other problems that we have to look at with patch management might be database. And databases, I've come across this a lot of times in my career, where databases don't get patched because if the front end works and then the operating system gets updated, we have to make sure the front end works. And then, oh, don't touch the database. You touch the database, it's going to break everything. I've come across database analysts, DBAs, and database administrators that will just absolutely refuse to update their database because they're worried about breaking the overall application. We can no longer do that in today's world. If we do that, then we absolutely introduce security risks. And so this is a constant fight that I've seen over my career. But let's talk a little bit about database tier models. So a one-tier model or single-tier environment is where we have a database and an application that exists on the same system. This is bad. This is very common in small-scale database deployments or systems that run a standalone database within them. A lot of early Linux and Unix implementations also worked this way, and each user that would sign on would have direct access to the database. So we've moved away from that to a two-tier model. And in a two-tier model, the client or workstation or the system that you're accessing runs the application on it itself. and then communicates with the database. This is typically called a thick client or a thick client model, and it basically communicates to the backend server. This is a very common implementation, like I said, in applications that run a thick client. A three-tier model, which is very effective, isolates the end user from the database by introducing a middleware server or a proxy. And this proxy accepts requests from the clients, evaluates them, and then sends them on to the database server for processing only if authentication checks out. The database server then sends the data back to the middle tier server, and then that sends it back to the end client. So the client never ever touches the database server. This is a very secure methodology of accessing data. However, it's a very expensive methodology for accessing data. All right. So database security is a big issue, and a lot of times if we do not take database security into as an issue, we lose data. And DBAs over the last decade or so have gotten a lot better about addressing security, more so than developers have. Secure configurations of databases is probably one of the most often causes of findings in an audit, because again, like I had said before, a lot of DBAs refuse or they don't want to have a change made in their environment because they're worried about breaking something. So let's talk a little about NoSQL versus SQL. So there are two different types of databases. There's NoSQL versus SQL. So standard query language, one database that does not use it and one database that does. So the database type in non-SQL or NoSQL is non-relational, and it's distributed, meaning that we're not going to use keys. We're not going to have a primary key or secondary key, whereas in a SQL we will. We can be able to query things with those keys in place. The schema type in NoSQL is very dynamic, meaning that we can add records and we can add tables as we like, whereas in an SQL database they're defined. Storage-wise, you can see here there are different types of methodologies as well as benefits. That fourth line down there, that's the one you need to read and understand. So NoSQL databases can handle large volumes of structured, semi-structured, and unstructured data. This is really good if we have a lot of data to collect very quickly. It can amass this in a dynamic fashion. Whereas with an SQL database, we are defining the data that we're going to receive. And it is widely supported across many different types of platforms. Okay, so that is going to conclude our lecture for this week. So I want to thank you guys for tuning in. Let's just take a real quick look at our... Oh yeah, we have we have an assignment, I believe, that is due this week. Let's take a look at the syllabus. Or is it next week? I can't. Oh, we have quiz 3 that is due this week, and lab 2 is due next week. So I'm going to be posting a new lab 2 walkthrough here today, hopefully in the next couple of hours. So you should see that in week 9. I'll also make sure I put it in week 10 as well, at least the link to it, so that you guys have it. And that's going to do it here for week 9. So be on the lookout for that lab 2 walkthrough, and make sure that you take quiz number 3 if you've not already done so. So this is Professor Brown signing off. We'll see you in week 10.